Hello, so this is quadratic for GCSE Higher. We try to give you one type of questions for every type. Okay, questions. First one is factorizing the simpler ones where the coefficient of x squared terms or t squared term is not anything other than 1. Okay, so we do need to do what? We have to find two numbers which add to give you negative 30 and times to give you plus 144. 144 is a bigger number, so 1 and 144 doesn't work. 2 and 72 doesn't work. 3 I think goes into it as well, so 48 I think doesn't work. 4 goes into it as well. 4, 3 and 36 I think doesn't work. Okay, 5 doesn't go into it. 6 does. Let's check. 6 and 24, so they can give me 30. So I'm looking at -6 and -24, so my factors are x minus 6 and x minus 24. Okay, so what do we do now? We need to, if they ask you to factorize, just stop here. If they ask you to hence solve the equation by factorizing, so you do what? You rewrite that. And then you equate both factors to 0 and work out the two values of x, or the two solutions, or two roots, as we call it later on at A-level mathematics. Okay. So second type, which is called harder factorizing. So let's do this one here. Coefficient of x squared is not 1. So I've got a different method. I'll do it by that method. Okay, guys, I want two numbers which add to give you +4 and times to give you first times the last, which is 4 times -3 is -12. Okay, that tells me because I've multiplied this last one by 4, I have to divide by 4 at some point. Okay, the numbers are 2 and 6, and this is +6 and -2. What I'm going to do, people, I'll write these two numbers there, +6 and -2. Obviously, I've got that wrong. This is -2 and +6. Divide them by 4, and then comes the most important step. If you can simplify, you must. Okay, so here I can simplify both of them. So 2 into 2 is -1. There's a 2 there. 2 into 6 is +3 and 2 there. Okay. So what do you do then? You need to go bottom to top. I ask you to memorize it because you're putting them in brackets. Bracket starts with B, so bottom starts with B as well. So the two factors are 2x minus 1 and 2x plus 3. Okay, so these are the two factors. Right, if they ask me to factorize, I'd stop here. If they ask me to solve it, I'll write down two factors equals to 0, equate both the factors to 0 separately. You must show this step for you on making your understanding, okay, to the examiner. So add 1, 2x is equal to 1, divide by 2, so x is equal to half, and take away 3, divide, so 2x is equal to -3, divide by 2, x is equal to -3/2. So these are the solutions of this quadratic equation, or x-intercepts of quadratic function, or roots of quadratic function. Whenever the question says solve an equation and find the answer to two decimal places, that's a clear hint that you cannot or may not be able to factorize this. Okay, what do you do then? You can use this formula. This formula is given in the formula sheet, if formula sheet is given to you. Okay, I would probably say memorize this. So wherever the word letter B is, I just put a bracket in there, and I can put brackets here as well, just to show the multiplication. It helps for the negative numbers. Okay, step 1. Identify what your A is. A is 3. What's B? B is -1. And what's C? C is -5. Okay, must show that's this step now. Into the formula negative -1 plus minus. Okay, then you would -1 whole squared -4 times 3 times -5 over 2 times 3. You must show this step before you put this in the calculator. Reason for that, that if you get something wrong in calculator, you should get full method marks for this. Okay, then put this in the calculator, work out the two answers. So these are the two answers for this one. Then we can do rest of all these questions using the same formula method. Next type, completing square, writing in this form, the easier of the two completing squares, then hence solve the equation using completing squares. So I want to do this first question. Okay, we do completing square for the first two terms. We write them as a whole squared to take away something squared, then one last term. Then what do we do in here, people? X, and then always half. Okay, same sign, whatever is in there, 2, and this is always take away 2 squared. So x plus 2 squared minus 4 minus 6. So x plus 2 squared minus 10. So this is what they've asked me to do, right in this form. And hence, how do I solve this equation from here? If they ask me to solve using completing squares, so I'll first do completing square, which I did on the left, equals to 0. Then I do step by step. People take 10 to the other side or add 10 to both sides. So x plus 2 squared is equal to 10. Then I do square root. So x plus 2 is equal to square root of 10. That should be plus and minus. Okay. And then I take this minus 2 to the other side, becomes minus 2. So x equals minus 2 plus minus square root of 10. If they ask me to leave answer in third form, this is correct. If they do not ask me to leave answer in any form, this is still correct. If they ask me to find answer in decimal places, I put this in the calculator one by one, minus 2 plus root 10, minus 2 minus root 10. Okay, that's how we solve the equation using completing square, the simpler method. The next thing which comes is completing square, the harder method. Okay, when the first x square has a number in front of it, so what do? We take that number out first. We don't factorize it completely, just take that number out. So x square is alone. Leave x is inside. Okay, I normally put this in the square bracket. Then I do what I do is completing square for the square bracket. That means inside it, I write down a circular bracket, take away something squared. That gives you x plus 3 over 2. 3 over 2. Yes, it can be fractions as well. Okay. So x plus 3 over 2 squared minus 9 over 4 and minus 7. Then we multiply them. So 4x plus 3 over 2 squared. So 9 over 4 times by 4 is minus 9 and minus 7. So finally I get 4x plus 3 over 2 squared and minus 16. Okay, this is the completed square, starting in the form of a x plus b whole squared plus c. Okay. Right, so I will now teach you how do we solve equations using completing square. Same thing like we did in the last one. So here is the completed square form of this expansion. Okay, then we add 13 to both sides. Then we divide by 3. Then we do what it will be square root it. So I'm starting from here, save space, square root of 13 over 3 plus minus. And finally, I do what people, I take 1 to the other side. X is equal to minus 1 plus minus square root of 13 full square root over 3. And these are two answers, minus 1 plus square root of 13 over 3 minus square root of 13 over 3. Then comes the question, how do you find the turning point of using a completing square? So we look for a completed square. Solution number 2, completed square form is 4x plus 3 over 2 squared minus 16. So turning points coordinates here would be, if they ask you to work out, this is negative 3 over 2, opposite sign of what's inside the bracket with x, and same sign of the outside number, that is a y coordinate. So turning point for this one would be 1, opposite of negative 1, and comma 2. Okay, that's how you find the turning points using completing square. All right, at the highest level of GCSE, they ask you to sketch the graph. So what do you need to do sketching graph? People, you need to do what? You need to find the nature, which could be u or an n, depending on if x square term is positive or negative. Okay, then you need to find the solutions, which is you're going to solve equation equals to 0. And then you need to find the y-intercept. That means you would substitute x equals 0 and find y and the turning point. So because of that turning point thing, it should be advisable if they ask you to sketch the graph. We should always try and solve this using completing square, because you need to do that for turning point anyway. Okay, so let's do that, people. So after finding these two solutions, and this is turning point, both solutions are negative. So, and if you substitute x equals 0 in it, 0 plus 0, so y-intercept is 1. So one here, two negative solutions. Turning point is somewhere -5/4 is negative as well on all the negative quadrants. People, this is the graph of that function. It passes through 1 there, and turning point's coordinates are -5/4 and 17/4, -5/4 and -17/8. Okay, that's how I find it and sketch the graphs.